Hey guys, hey, this is Miss Carson. So I wanted to go through the last few, I'm kind of compiling a bunch of different stuff for the last chapter. It's going to cover polar, going from polar to rectangular, being able to graph polar. You should be able to graph rectangular, being able to graph a polar equation in your calculator, and then also some information about vectors. So I just wanted to go over myself a little bit of the topics that can be a little bit tricky for you guys. So first, what I want to do is let's take a look at on Moodle real quick. All right, so when you open it up this last week, I just want to remind you guys that this will be the last week of material. I'm going to post an announcement. Make sure you guys fill out the course evaluation. And then also go ahead and start studying for your final after this week, which will be due on the 9th. Your final will open up from the 10th through the 15th. And I would suggest just studying old tests and your notes from my open math, and you should be good to go. Most of the test questions come from old previous exams. So the first video I want you guys to watch is the polar coordinates. This is a really good video on how to graph polar coordinates, how to go from a polar to a rectangular coordinate. And then here are a few notes on, let me pull this up, on polar equations. And this is a little bit a part of, if you did buy the book, the big book that I told you guys you didn't have to. In chapter 11, there's some key information on how to use the general formula to determine whether something is a line, a hyperbola, an ellipse, a circle, or a parabola. So when you take your polar coordinate and you convert it to a rectangular, you guys should be able to determine whether it's a line, hyperbola, ellipse, circle, or parabola. This is the only thing that I'm going to cover in the conics section, so I want you guys to be able to do that. When you guys convert something and you get it in the form of y equals mx plus b, meaning there's only one x and only one y, then you know it's going to be a line. If you get it into the rectangular form and your a and your c, meaning the numbers in front of x squared and y squared, are negative, okay, if you multiply them, obviously this is 4 times negative 4. If you get them and they're negative, that means it's going to be a hyperbola. If you get your number in front of your x squared and your y squared and they're positive, means that it's an ellipse, okay? Like this, 2 times 4 is 8, that's positive, so it's an ellipse. If the number in front of the x squared and the y squared are the same, okay, are the same, and they're positive, okay, then it's a circle. And then the parabola is when you only have either just an x squared or just a y squared. You're not going to have both squared, all right? So I'm going to walk through some of this part with you guys because this part can be a little bit confusing, but I just wanted to go back and show you guys that. So make sure you take a look at that. And then this is in some more notes on how to convert from polar equation to rectangular. This is a video on how to put in the calculator. I'm going to post another video up here of myself talking, so make sure you watch that one too. And then this last video is on vectors, which I think is a pretty simple concept. So let me get you guys to whiteboard. All right, so let's say we have a problem like this. R equals 4 over 1 minus cosine of theta. And first, this is in polar coordinates. I want to be able to first convert it to rectangular. So we want to convert to rectangular. And then I want to be able to determine what kind of conic it is. Okay, so to do that, we need to get rid of the denominator first. So how do we do this? Well, we multiply it by the denominator on both sides. So I'll multiply it on both sides by this. And those will cancel. And then you're left with 1 minus cosine of theta times r equals 4. Okay, and then we need to distribute. Okay, so this is r minus r cosine of theta equals 4. And then if you think back to your rectangular coordinates, right, what does r cosine of theta represent? Well, it represents x, right? And y represents r sine of theta, okay? And then we know that x squared plus y squared equals theta is one that may help you. And then, what was the other one? Oh, we'll get to the other one. All right, so I know this is going to be x, and then we have this. All right, so the only thing left to do now is, well, we need to get rid of this r, but to do that first, I'm going to move the x over, and you're left with r equals 4 plus x. Now, wait, this should be not theta, r squared. X squared plus y squared equals r squared. So I know that if I squared this r, then I can replace that with x squared plus y squared. So what you need to do is we need to square this side, and if we square this side, we must also square that side. And so now you're left with r squared equals 4 plus x times 4 plus x. And then I know that r squared is the same thing as x squared plus y squared. And we can FOIL this. That's 16 plus 4x plus 4x plus x squared. And that's 16 plus 8x plus x squared equals this side. All right, and then we want to get it in that general form that I showed you guys on those notes, okay? So I want to get everything on one side. So what I'm going to do is I'm going to move all of this over to the other side. So when I do that, your x squared, so this is what our problem looks like. Okay, I'm going to rewrite it. When I do this, notice what happens to your x squares. They go away, and you're left with this. And then I'm going to move everything over. So y squared minus 8x minus 16 equals 0. Okay? And you could leave it like this. And notice we only have one squared, so we should know that this is going to be a parabola. I'm not going to require you right now to graph this, but this is a parabola. Okay? All right, so let's do another one. All right, let's say we have r equals 8 over 2 plus 4 cosine of theta. Okay, again, you want to put it in rectangular form. So I'm going to move both of these over. That will cancel. We need to distribute. So it's 2r plus 4r cosine of theta equals 8. And again, what is r cosine of theta? It's going to be x, so this will be 4x plus 2r equals 8. I want to get this by itself, so I'm going to move this over. So we're left with 2r equals 8 minus 4x. And then what do we do next? All right, so we want to get rid of the r. What I would do first is get rid of this 2, so we could go ahead and divide everything by 2. So then r equals 4 minus 2x, and then now we can square this. So then this is going to become x squared plus y squared equals 4 minus 2x times 4 minus 2x. And then we end up with 16 minus 8x minus 8x plus 4x squared equals this. And then now let's take a look. X squared plus y squared equals 16 minus, that's going to be what? Minus 8x minus 8x is going to be 16. All right, so I want to move everything over. So minus 4x squared. So it's going to give you negative 3x squared plus y squared plus 16x minus 16 equals 0. So notice here, this is a 1, this is a negative 3. If you multiply your x squared and your y squared, the coefficient in front of those, it's going to give you a negative, which means that it's going to be a hyperbola. right? Did I do something wrong? Yes, I did. No. No, I think I did that right. So, all right. Let's see. I wanted to do another one. What if I gave you something like r equals 3? How would I do a problem like this? Well, we can do it similarly as the other ones. How can I get rid of r? Well, you can square it. You can square it. So r squared equals 9. Okay, and then we know this is x squared plus y squared equals 9. Now think about this. What are the coefficients in front of you? They're the same, so that makes this a circle. And to graph a circle, remember, okay, this goes back to algebra, your center here would be 0, 0, and your radius would be 3. Okay, so 0, 0, and then 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is not perfect, but just imagine those go through here. Okay. All right, so there's one example. How about if you had something like this, theta equals pi over 4. You know, that's 45 degrees, right? So imagine, here's pi over 4, here's pi over 4. What is that going to make? That's going to make a line. And just think about it. How can we get rid of a theta? Well, we can take the tangent of that. Okay, and we know this is y over x equals pi over, well, tangent of pi over 4 is what? What is tangent of pi over 4? Think about pi over 4, that's square root of 2 over 2. Square root of 2 over 2, that's going to be a 1, right? So tangent of pi over 4 is going to be equal to 1, and then how do you solve that? Well, that's going to be y equal to x. Okay, so that would be the equation for that, and we know that it's a line. So yeah, that's the gist of the other part. There's going to be several questions like this on your test for this chapter. Let me know if you have any questions.